So I thought I'd make a quick little video to show you around your density lab. This is week 3 density. Click here and this opens up. The option to look at this video will be here. Okay, so you have modular overview, and then we have density characteristic background, and that is right here. You need to look through here and read this. This is a description. It tells you about what density is. I'm not going to go through it now, but you need to read about measuring mass, measuring volume, and measuring the volume of a solid. Okay? Help you really understand the lab as you do it, if you'll take the time to read this. Go back to module. Then we've got, I'm going to skip down here to this. This is your density outline, and you're going to need to download the lab report form. That, it's right here. Download it, save it. And naturally it comes up over here where you can't see it. There we go, move it over here. This is what you're going to fill out. So you'll download this document and you'll put in the title. Remove all my blue instructions and put in the title. The title of this lab is Density, a Characteristic Property. Then you'll need to put in a purpose. It needs to be 2 to 3 complete sentences, and you'll get ideas from this from reading that background section that I was just telling you about. The background needs to be a well-written paragraph. And again, that background section can be very helpful, but you can use other sources as well. I wanted you to tell me what density is. How do I calculate density? The title of this lab indicates that density is a characteristic property. So what does that mean? What does it mean to be a characteristic property? And what are other characteristic properties, and how are they used? So that gives us some background. The procedure section is also very important. I want you to summarize the procedure. Do not copy the lab manual. I want you to read the lab manual and then summarize it. Tell me what it said. For example, experiment 1 of this lab can be summarized in very few words. It doesn't have to be long, but you need to read it, understand it, and then tell me what you're going to do. Okay? So the purpose, procedure, and background sections need to be written really before you go into the lab. So now we're ready to go into the lab. I'm going to get rid of this. The lab is here. Oh, I guess we go here. This is the procedures, and you'll need to, this is what you're going to read to summarize. But do not copy and paste it. I will not give you credit for that. You enter the virtual lab through this link right here. It's pretty small, but that's where you click this and the lab will come up. You have to click that you're going to wear safety goggles, a lab coat, and gloves, and we're ready to enter the lab. I think I'm going to have to move my face before I can enter the lab. There we go. All right. Now you've been here before, so you sort of know how things work, and you have your directions as to what you're supposed to do. That's in your procedures. So you'll follow the procedures carefully, and then you'll need to fill out this table. So this is the first experiment. Trial 1 with water. Okay, so we're using water. We'll put in the mass of the graduated cylinder in this column, the total mass of the graduated cylinder and the water in the next column, and in the third column, you'll put the mass of the water. Now, how do you know the mass of the water? Because we didn't measure that, right? We did measure the mass of the graduated cylinder and water, and the mass of the graduated cylinder alone. So the mass of the water will be equal to the mass of the graduated cylinder and water minus the mass of just the graduated cylinder. So if you take the second column and subtract off the first column, you will get the mass of the water. So I always forget that y'all can't see my cursor. We'll do that. Okay. So if we call this column 1 and this column 2, if we take column 2 and subtract 1, we'll get this column right here. The volume of the water you'll read directly off the graduated cylinder, and the density of the water will be the mass, which is right here, divided by the volume, which is right here. Okay, so the density should stay pretty constant. Remember, density is a characteristic property, so it should not change. You repeat the same procedure down here for the ethanol. And then basically the same procedure a third time for our unknown liquid. You'll be able to use this table. Hopefully one of your densities will line up and you'll be able to put that figure out the unknown liquid. Because it's a characteristic property, it can be used to identify. All right, now we've got the density of various metals. So you'll start by writing down the mass of the iron, the starting volume of the water, which will not change, it'll be the same, the final volume of the water plus the iron, and then the volume of the iron. So we measure this one. This is 1 and this is 2. These are both measured. We look at the graduated cylinder to determine the volumes. The volume of the iron is the difference in the two. So if we take column 2 and subtract column 1, I'm calling the ones I've labeled 1 and 2, columns 1 and 2. That will give us the volume of the iron. So make sure that you use the volume of the iron when you do your density, not one of these two, not the volume of the water or the volume of the water plus the iron. We want the volume of the iron by itself, and that's the difference in these two columns. Okay, the density is going to be equal to the mass, which is this one right here, divided by the volume of the iron, which is this one. Okay? And again, these numbers should be similar to one another. May not be identical due to measuring errors, but they should be similar. If you start getting weird numbers, you know you've done something wrong. Okay, you basically do the same thing for aluminum and for an unknown. You're given a density table and you should be able to identify your unknown, hopefully. For the conclusion, we need a well-crafted well-crafted paragraph. Make sure you answer these questions and restate your data. In scientific journals, people frequently turn immediately, if they're going to look at a paper, they turn immediately to the conclusion. They read the conclusion first to decide whether they're going to read the whole paper or not. So you restate everything kind of that you've already said, even though you've already said it. Okay, then we've got a couple problems, 3 problems to work, and you'll be all done. Good luck. Be sure to contact me if you have any questions about any of this. I'm here to help you.